In this video, we're going to work out these two trigonometric integrals. So if you notice, both of these problems, they have powers. So this one has power of 2, even powers. These, we have odd powers. So we're going to treat them slightly differently. So let's work on the first problem, see how to deal with even powers. So if you have even powers, you want to use this rule. We know that sine squared of x is equal to 1/2 1 minus cosine 2x. So that's the formula you want to use, or the identity for even powers. Similarly, for cosine squared x, we're going to use 1/2 1 plus cosine of 2x. For odd powers, we're going to work on a little bit later. Now I see that I have a sine squared, cosine squared of x. I'm going to go ahead and apply these two identities and simplify it algebraically. Let's go ahead and do that. So 16, we can pull it outside the integral. Sine squared x, we'll replace it with 1/2 1 minus cosine 2x. And cosine squared x, we replace it with 1/2 1 plus cosine of 2x dx. And now these two factors, 1/2 and 1/2, I can push them outside. So that's 1/4. We have 16 over 4. The integral of 1 minus cosine 2x times 1 plus cosine 2x dx. Now let's go ahead and expand this. So if I expand the inside of this integral, we will have 1. So cosine 2x and negative cosine 2x, the middle terms will cancel out. And then the last terms will get negative cosine squared of 2x dx. So that's what you get when you expand this. So simply distributing them. All right, now let's separate this into two integrals. So we have 4 outside, we're integrating 1 respect to x, and then minus, we're integrating cosine squared of 2x dx, and everything gets multiplied by 4. Now here again, you ended up with the even power. Again, use this identity. Even power, always use that identity. So we're going to have to rewrite this identity a little, since we're having the angle to be 2x instead of just x. So we know that cosine squared of x is equal to 1/2 1 plus cosine 2x. Now we don't have cosine squared of x, we have cosine squared of 2x. So we have to rewrite it as this. Cosine squared of 2x is going to be 1/2 1 plus cosine of 2 times 2x. So it becomes 4x. And that's where I'm going to replace with cosine squared of 2x. So just to rewrite it nicely, this is 1/2 1 plus cosine of 4x. That's what we're going to replace right here. So our integral, we can rewrite it using this same identity. We have 4 times the integral. Now you can integrate 1. We know that's going to be just x. Minus, so I rewrite the second piece. The integral cosine squared of 2x, that's going to be 1/2 1 plus cosine of 4x dx. And the 1/2, we can pull it outside. Now we can integrate all of these. So we have 4 times x minus 1/2, the integral of 1 dx. And then let's put, I guess I can distribute the 1/2 too, so we don't have too much to take care of at the end. So that's 1/2 times integral of 1x, and then minus 1/2 the integral of cosine of 4x dx. So at the end, I'm just going to distribute the 4. All right, so now this will give us the following. We have 4 times x minus the integral of 1, well, that will just be x, so this is 1/2 x minus 1/2 integral of cosine of 4x, that's going to be sine of 4x over 4. We're finished, now we add plus c. So now let's clear this up. So we distribute the 4 and simplify. And if you want, you can combine these as well. Let's do that afterwards. So we have 4x minus 4 over 2x, so that's just going to be 2x minus the 4 and the 4 from bottom of sine 4x will cancel. So you'll just have 1x, 1 over 2 sine of 4x plus c. So that is our answer to this integral. Now let's work out this one where we have odd powers for sine and cosine, both of them. So when you see odd powers, you want to think of using this identity. Sine squared of x plus cosine squared of x is equal to 1. So even powers, we used the double angle previously. For odd powers, you use this Pythagorean's identity. And you can isolate for either sine squared x or cosine squared x. So what you want to do is you want to factor out either one factor of sine or cosine. So you can choose. I'm going to go ahead and choose to factor out one factor of cosine from here. So here's how I'm going to rewrite this. So the integral of sine to the 5th x, let's keep the sign as it is. For cosine, I'm going to pull out one factor of cosine. So you have cosine to the 4th times cosine of x dx. Now you could have pull out a factor of sine. That's also fine. Either way, the integral will work out nicely. Now, once I do this, I'm going to rewrite this piece in terms of sine so that I have everything in terms of sine, and I reserve this one for my du portion, and you'll see why. So you factor out one of the cosine, rewrite everything in terms of sine. So I know that I can write cosine to the 4th as follows. So you have sine to the 5th x, cosine to the 2nd, and all of that squared because that's same thing as cosine to the 4th, and cosine of x dx. So just a little bit of rewriting. Now what is cosine squared x? Well, from here, you know that cosine squared x is equal to 1 minus sine squared x. And that's what I'm going to plug in right here. So I will have everything in terms of sine, and I'll reserve one factor of cosine. So let's do this. So we have the integral of sine to the 5th x, and cosine squared x, we're replacing it with 1 minus sine squared of x squared times cosine of x dx. Now we can start using u sub. We're going to let u to be sine x. So everywhere you see sine, you replace it with u. So this will be u, and this will be u. And we know that derivative of u would be cosine of x dx. And that's why we save this. This is our du. So now if I replace my entire integrand in terms of u and du, it will look like this. So our integral is equal to u to the 5th, because this is sine is u, so it's u to the 5th. Then we have 1 minus u squared. Again, right here, this is u. So it's u squared squared, and cosine x dx. That is our du. So you see how everything worked out really nicely. Now just simplify this and then integrate. So 1 minus u squared, if you expand that, so 1 minus u squared times 1 minus u squared, that's going to be 1 minus 2u squared plus u to the 4th. So that's what this becomes. So you have u to the 5th times 1 minus 2u squared plus u to the 4th du. And then here we expand this part out completely. So that will give us the final form to integrate. We will have the integral of u to the 5th minus 2, using the laws of exponents, we add their exponents, u to the 7th plus u to the 9th. And we're integrating respect to u. Now we're ready to integrate this using the power rule of integration. So integral of u to the 5th, that's u to the 6th over 6, minus 2 times u to the 8th over 8, plus u to the 10th over 10 plus c. So we're finished integrating. You can simplify. So this I can simplify. Everything else doesn't simplify, so we replace what u is. U is right here, sine of x. So I'm going to replace that. So our final answer is going to be 1/6 sine to the 6th of x minus 2 over 8, that's 1/4 sine to the 8th of x plus 1/10 sine to the 10th of x plus c. So that is our final answer for this problem. Okay. So I hope these integrals are easy to compute.